Okay, analysing or describing histograms. We're actually going to discuss histograms, but we will also include in this conversation the dot plots, because they use those once in a while in this course, or the stem and leaf plots, because in appearance they're similar looking in terms of you can see the shapes and whatnot in the same sort of way. And so we'll also extend our conversation into those things as well. But the bulk of the course tends to focus on histograms and box plots, so we'll do histograms in this video and box plots in another. Okay, in describing any statistics, it's typically a 3-mark question, and you always need to discuss 3 things. The first thing is the measures of centre, the second thing is the measure of spread, and the third thing is a discussion of the shape. Okay, and by shape we mean is it symmetrical, is it asymmetrical, which would mean it's negatively skewed or positively skewed, or other things like shape, like is it unimodal, bimodal, is it are there gaps, are there clusters, and all those sorts of things. So all of that would come under the shape. Now, before we start discussing all these things, I'll do the brief summary. So measures of centre include a mean, median or mode. Measures of spread would include range, interquartile range and or standard deviation, and the shape we've just discussed is all those sort of other things. Now, what you've got to consider is the purpose of describing the statistics. So when you're asked to describe statistics, you're trying to tell your audience about what's actually happened. And so which measures are appropriate to use always depend on how the data sort of turned out. And so, as I say, measures of centre, mean, median or mode, you can actually calculate all 3 of these with a histogram. You can't with a box plot. You can see the median, but you physically cannot calculate a mean. And you can't calculate a mode because you can't see it. You know where the data is spread, but you don't know where the individual data items are on those things. So for a histogram, all 3 of these are possible, but it doesn't mean that they're the best measures to use. And I'm just going to explain that. So, and this is where the shape and that kind of thing also comes in. So if my data was, and I'm just going to draw a little picture on the bottom here, there, squeeze it in. So if I had a histogram that was lovely and symmetrical, and they'll never be perfectly symmetrical, but when we describe it, we'd say, approximately symmetrical or something like that. But if my data is pretty much symmetrical, then what I know is that both my mean and my median are going to be equal to each other. So my mean is equal to my median. And the purpose of describing the data, as I say, is to tell the audience where the information is, where most of the data is happening. So in this case, most of the data is happening in the centre. So using the mean or the median or both makes perfect sense. And so it would be worthwhile calculating that. However, if my data was not symmetrical, and I'll give a couple of examples of this. So if I had in an extreme situation, I might have something like this. This is still symmetrical, I might add. So I should be careful in using that word symmetrical. It's not the symmetry that poses the problem, but the symmetry combined with where the data is falling. This second graph that I've just drawn on the bottom is also symmetrical, but what you can see here is that the bulk of the data is actually on the outside. And so we would call this bimodal, and that bimodal nature means that really the mode in this instance would be the better statistic to provide rather than the mean or the median. Because if I calculate the mean or the median, then both the mean and the median are going to sit in the centre because it's symmetrical. But it's not really where the data is, and the purpose is to tell people where is the data, and the data's not there. The bulk of the data is actually on the outsides. So if I had my data that looked like that, then my mode would be the better indicator to provide. And so sometimes you need to make that judgment call. If you've got time and they're fairly obvious to see, give all the information, but if you don't, then be sensible about it. And this is where describing the shape is also very important, because if I did provide the mean and the median in this second instance, I'd want to clarify that by saying, well, actually most of the data is not there, but it's actually at these bimodal points of whatever they are. I could have skewed data, and so again, if I try and squeeze a third one in here, so if I had data, let's say, shaped like this, in this case you can see that tail drapes off into the positive direction, and so we would say that this is positively skewed because it's the tail that determines where the skewing is. In this case, I know that the mean and the median won't be equal to each other. Those numbers towards the top end are going to drag that mean up. So if I had a positively skewed situation, then my mean is going to be greater than my median. So in this case, you know, I might provide both of those things, but that information about the shape clarifies us so that we know where the data is actually happening, and we can kind of make a few more, you know, guesses about what's going to happen in the future and so on. So that's that. It's all possible. Now, before I move on from measures of centre, we need to discuss how we actually calculate those things. So what you can see, I've given you the little formulas here. To calculate the mean, we know it's the sum of the numbers divided by the number of the numbers, but getting those from a histogram isn't always that easy. What we need to remember is it's the sum. Often our data is grouped in these circumstances, so we must use the midpoints. So it's the sum of each midpoint times the frequency divided by the number. So let's have a look at a couple of histograms. Come down to one with some extra numbers. So if I was presented with this information here, there's a couple of ways they present histograms, and I'll show you both. So on this first one, you can see that they've used the number that they've given is in fact already the midpoint. So the data itself really, in this case, is going from 5 to 15, and then on this next end of it would be 25. And so that block is really 15 to 25. The next bar is really 25 to 35 and so on. But what they've shown on the axis is the midpoint, and it's the midpoints that we're going to use to do this calculation. But if I had my graph presented like this one, what they've given me are the cutoffs, but what I'd need in my calculation would still be those midpoints. So in this case, 15, 25 and whatnot. These ones were fairly obvious what the midpoints are going to be. However, sometimes it's not quite as clear. If you forget, then just use the two cutoffs and divide by 2. So in this case, you know, what we've effectively done is 10 plus 20 divided by 2 to get that 15 for my midpoint. So at times you might need to actually calculate those. But what we're trying to calculate here is the mean. So to get the mean, we know that my mean is equal to the sum of the scores divided by the number of scores. So to get the sum of the scores, basically if I was to look at this graph, I use the midpoint. So a score of 10 was my first one, but I actually had 4 of those scores. And so 10 happened 4 times, so I'd go 10 times 4. Plus, then I've got my next score is 20, and I'd have to check how many of those were there. So you can see up here there was 9 scores of 20, so I'd go 20 times 9, or 20 plus 20 plus 20, 9 times, but that would get tedious. Okay. Plus my next score was 30, and I'd come along and check that, and you can see I had 14 of those, so times 14, and so on and so on. You're going to keep adding up the sum of each of those ones, and then you're going to divide it by the number of scores. And to get the number of scores, that's basically equal to the sum of the frequency. So then you've got to go back and add up all these frequencies again. So you can see I'm going to add up 4 plus my 9 plus my 14 plus my 12. What's the next one? Plus another 5, and so on away you're going to go, plus 11 plus 15. I haven't drawn that very straight, but you can see that's 15 and so on. So you'd add up all the scores from the frequency. And that's going to allow you to calculate the mean. So it's not an easy process, and I wouldn't be doing it unless I actually did need to. So in this case, if I was actually presented with this data and asked to describe it, and I'll just get rid of some of this mess that I've drawn around the place. If I was actually to describe this particular distribution, then really the more probably important thing to focus on would be the fact that it appears to be bimodal. I can see I have 2 modes. So one absolute mode, you know, if you looked in your calculator, it's going to tell you that the absolute mode is not 70, but don't forget it's group data, so we talk about a modal class. So my modal class here would be a modal class of, let's write that down, so modal class of 65 to 75. Make sure you don't give just a midpoint. And if you'd entered this into your class pad, it's going to tell you that the mode is 70, but that would be would not get you full marks. You must bring it back to the modal class, which is my banded thing. So anyway, we've got the bimodal with my modal class of 65 to 75 and 25 to 35 would be my 2 classes because it was bimodal. And that bimodal information is probably the more important. When I came to describe that, I'd then say that it's basically symmetrical around each of the modes. So you can see if I did those shapes, roughly the data is symmetrical about each of those modes. So I'd be using those sorts of words to describe this. In comparison, if I looked at this next histogram and I was asked to describe that for my centre discussion, I would be again probably going to go with its unimodal. So I'd be talking about this unimodal class of, in this case, 20 to 30. And I'd need to start talking obviously about the shape here, which is positively skewed, which would give me that indicator that my mean is going to be higher than my median. So I sort of could implicitly know that. If I needed to calculate the mean, or if I had the time, I could still do that. But the mode is certainly the easiest measure of centre to pick off your histogram. So that's how you're going to calculate it. I was going to also just show you a couple of other graph types. So this one here is our stem and leaf plots. So you can visualise these in a similar way to a histogram. If I was to draw a line around this, just looking at where the numbers actually sit, I can still see that it's roughly symmetrical, and I can see that my sort of modal class is in the 60s. If I was going to group this data to make a histogram, basically most of my data is in the 60s, remembering that this first 9 here means that this is 19. The first number is my 10s, the second number is my 1s, this 9 here means 39, this 9 here means 49, and so on. So make sure you can remember how to interpret that. If I was calculating a mean for this data, then I could sum my numbers nice and easily. I'd just be doing my 19 plus my 39 plus my 47 plus 48, yada, yada, yada. Add up all your numbers, divide it by, and you can count up how many scores you've got there. They've told us, no, they haven't. So you just add them all up, divide by how many you've got, and you could certainly calculate a mean. And then in describing it, as I say, roughly symmetrical, you can talk about the mode. You're just finding the most common number. So again, in this case, you can actually see that quite easily. And you're just scanning through. The first one that's jumping out at me is probably that 66. Got any other doubles? No, and watch carefully, 73. There's also two 73s. And so you've got a couple of modes there, but it's unimodal. It's not. We haven't got a sort of bimodal sort of thing compared to this next one. Whereas if I drew the shapes around it, you can see I've kind of got my first mode in this region. Already regretting that shape. You can see I've got this bimodal kind of thing with my modes in the 30s or 70s, and then my data is roughly symmetrical around each of those modes. So, you know, that's a fairly loose description, but you can certainly, I just wanted you to be able to see that you can see those shapes. To get an actual mode, you'd be looking at the repetition of numbers, which one repeats the most, but we would still describe this as being roughly a bimodal. You know, if you imagine it being a histogram, you would be grouping it in the 30s and the 70s. Okay, I'll just take all this mess off here so we can use this again later. Okay, so that's the stem and leaves. The other one I wanted to show you was the dot plots, and I think I had one of those. They're up here somewhere. There we go. And so dot plots, again, are going to look similar to a histogram. If you're explaining this, you know, I've probably got an outlier over it in this region, and then again, I've got this bimodal kind of thing going on, where I've got two peaks, and my data's roughly symmetrical around each of those modes. And so when you're describing the centre, again, the modality here is more important than the actual mean. If I was going to calculate means and medians, you know, they're going to fall somewhere in this middle zone, and there's actually no data there. So we could certainly calculate them. We could add up each of the scores. I've got don't forget the scores on the bottom. So I've got a score of 3, and I've got one of those. I've got one score of 17, one score of 18, I've got 3 scores of 19, and so on. So we could certainly add up all the numbers, divide by how many there are, but it's not going to give us a feeling for where the data is actually sitting. So all that extra information is what you'd need to cover that. Okay, so that's our mean. Add them up, divide by how many there are, but use the midpoints. Median is much the same sort of thing. It's not an easy process. You can certainly take a guess from the shape, and you can see where the data's lying, so you can take a good educated guess at where your median is, but to calculate it is actually a little bit tedious. So go to one with some actual numbers on it. If I was calculating a median here, I'd need to add up how many numbers I've got, and I might just quickly go through this process because it's probably worthwhile. So I'll use a highlighter. So here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. That was tedious. Okay, so I've got 39 scores, and hopefully you'll remember that the median occurs at the n+1 divided by 2 place. So if I've got 39 scores, I'll go 39 plus 1 is 40, divided by 2 means it's in the 20th place. 20 is not my median, but it's the 20th place. Now these numbers are in order, so I'll change colours. So now I need to find the 20th score. So if I was counting them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and this next one is 20. So my median would be 34. And so certainly you can get it. As I say, it is painful. You could sort of roughly see that was what's going to happen, that it was going to wind up somewhere in that direction, but certainly not in the not in the peak or the centre. But we can work it out. If we had a histogram, then to get the median, you've got to do the same kind of thing. You will have already calculated the sum of the frequencies, hopefully, but if not, you'd have to do that. So again, you're going to go 4 plus 9 plus 14 and so on. Add them all up to work out how many scores you've got. Do the +1 divided by 2 to find the place, and then you've got to go through that process again. The only other option you've got with that is to do like a table with a cumulative frequency. So in those cases, we had a score, and then we'd have our frequency, and then we'd have our cumulative frequency, and that's where you add them up. So in this case, we had 4, and then we've got 9, and then we've got 13, and 13, and so on. And I won't finish it, but cumulative frequency, we'd have 4, and you're adding always the next one. So 4 plus the 9 would give me 13, plus the next 13 would give me 26, and I'd keep going like that and add them all up. At the bottom, I should get the sum of the frequencies number. But that would allow me to find that location of the centre. So let's say if I finish that there, instead of using that whole histogram, if I had 26, then I know it's going to be at 13.5. Well, at 13, I haven't here. I hit the 13th number there, but I haven't quite got it. So it's going to be in between that one and the next one. And so then I would read that off. So my scores here were 10, 20, 30. So I know it's going to be in between my 20 and my 30. So my median would come out at about that 25. So you have got the option of doing that sort of thing as well. So a little bit painful, but that's the process you're going to need to use. Same if you had those stem and leaf graphs. So if I come back to one of those, you need to add up how many there are, do the n+1 divided by 2 thing to find which location. And the only trap you really need to watch with these is that you need to make sure your numbers are ordered. So you'll see here that these aren't actually ordered. So I've got 47, then I've got 48, then I go back to 44 and so on. So if you're using a stem and leaf, you've got to first make sure that it's what we call an ordered stem and leaf. So where I've got more than one number, I'd be rearranging these into order so that I can then, when I find those medians, I've started from lowest to highest, and then I'm going through that way. So watch out for that. So that is my measures of centre. Mode is nice and easy, of course. On these, you're just looking for your tallest bar. So here, if I'm looking at my mode, I've got a modal score there of 5 and so on. So they're nice and simple to read. And so for 3 marks, if I was given a histogram, and I literally am going to aim for 1 mark for my centre, 1 mark for my spread, 1 mark for my shape, then I would certainly, in a histogram situation, mode is your best one, easiest one to go for, unless they've asked you the question that it's clear that they want something else. So that's measures of centre. Measures of spread are range, which is your maximum, take your minimum, interquartile range and your standard deviation. Now, all of these are possible. The range you can see pretty much at a glance on these. However, you need to be really careful about the grouped data. If I had data like this, I can see my range really simple. I've got 3 as my minimum, and I've got 39 as my maximum. So my range would be, range will be 39, take away my, 3. Okay, so I'm going to have a range here of 36. However, if I had grouped data, like we have in both of these histograms, then you need to be careful, as I say, that we actually don't know. I know that there's like 5 scores in this N bar. I'll highlight so you can see where I'm looking. If I'm in this N bar, there's 5 scores there, but all 5 could be at the 85 mark, or all 5 could be at the 95 mark, or they could be anywhere in between. I don't actually know where they are. So I'm not guaranteed that there is in fact a score of 95, and I'm not in fact guaranteed that there is a score of 5. So I could say there's a maximum range here of 95, take the 5, so a maximum range of 90, or a potential range of 90 is the kind of language I should use, but I can't just say the range is 90 because I don't in fact actually know that. So just watch the way you phrase those sorts of statements. Standard deviation, you won't be asked to calculate that yourself, but if you were entering stuff into your class pad, then you'll use those midpoints. And the interquartile range, again, it's possible, but it would be painful. So if asked in an exam for a range on a histogram, then your best bet is to ask for a measure of spread or to describe the thing. Then certainly range is your easiest measure to go with, and you'll just go with that approximate range of whatever the maximum take the minimum is. And that brings us to our last statement, which must always be about shape. And again, we know it's either going to be symmetrical, like this first one, where it's sort of mirror imaged. This second one is also still symmetrical, but it's bimodal, so you would need to discuss the bimodality and the symmetry around those points. This last one is also symmetrical, but that's what we call uniformly distributed. And so really, it's more that uniform distribution that you'd need to comment on. So uniformly distributed is the way I'd describe that one. But certainly symmetry, is it symmetrical or is it asymmetrical? If it's asymmetrical, then it's either positively skewed or negatively skewed. If it's positively skewed, then that tail is going to come out to the right. I did not mean to rub that down, I meant to highlight it, sorry. The tail's coming out. So visualise your number line. Starting from 0, you'd be going up 1, 2 in positive direction, or -1, -2 if you're going back the other way. So visualise the direction your tail's going. If it's heading towards the positive side, it's positively skewed. And that would tell me that my average is going to be dragged up by these higher numbers, and so I know that my mean will be greater than my median. And so if I have the raw data as well, often they'll ask you to comment on the shape. If you can't pick it for sure from looking at it, then compare the mean and median. If my tail's dragging off to the left, then I know that it's tending towards the negative side, and so it would be negatively skewed. And you must also comment on anything else that's unusual. So are there outliers, obvious outliers? So in this case, I had a very obvious outlier out here. Are there gaps? So in this case, I've also got these massive gaps that I'd be commenting on, and clusters. And so again, this is a nice example that I've got these clusters here. If I showed you another one here, I'd be talking about this being negatively skewed. I'd mention the gaps over here, and with the bulk of the data being clustered in this main zone. And so you'd comment on anything like that. And I'll just see, the last ones we had were the stem and leaves, and it's the same sort of thing. So here I can talk about it being bimodal in shape, but symmetrical around those points, and again being symmetrical here with a gap, if there's gaps and that sort of thing. Okay, and that's it. So golden rule is centre, spread and shape, and make sure you comment on one of each of those things, and try and make sure that it's the easiest one. If you only got 3 marks, mark a minute, pick the easiest ones unless you have lots of time. Thank you.